For decades, we have looked beyond our solar system for signs of intelligent life. But what if we've been looking in the wrong place? 370 kilometers long, 3 massive hollow cylinders, a catastrophic breach exposing what appears to be a landmass inside. This is Trojan 1, and now we are sending a mission to investigate. Trojan 1 was first detected in Jupiter's L4 Trojan point, a region where asteroids remain in stable orbits. But Trojan 1 is no ordinary asteroid. It is a colossal segmented megastructure, evidence of an intelligence beyond our own.
The upcoming ITRC-led exploration of Trojan 1 has been designated Project Argonaut, referencing the legendary voyage of discovery. Mission phases: Phase 1, high-resolution scanning and spectral analysis, 6 months unmanned. Complete orbital mapping of Trojan 1, deep penetration radar scanning to locate internal structures, spectral analysis of the breach to determine whether any atmospheric remnants persist. Phase 2, first probe deployment, 12 to 18 months, unmanned. 4 specialized probes will be launched, each assigned a critical function: Odysseus, USA, surface mapping and radar imaging; Aeneas, Europe, signal interception and communications analysis; Juche, China, subsurface and internal scanning; Agni, India, energy signature detection and AI analysis. Each probe will target different sections of Trojan 1 with a primary focus on investigating the breach in Cylinder 1. In the meantime, when Trojan 1 is positioned on the opposite side of the Sun from Earth, direct observation and communication become challenging due to solar interference. However, several assets across the solar system can be utilized to continue monitoring and relaying data about Trojan 1 during this period. Spacecraft near Jupiter. Juno. Currently orbiting Jupiter, Juno is equipped with instruments capable of observing Jupiter's environment. While its primary mission focuses on Jupiter itself, Juno could potentially capture data on Trojan 1, especially if it passes within observational range. Lucy. Launched in 2021, Lucy is on a mission to study Jupiter's Trojan asteroids. Its trajectory includes flybys of the L4 and L5 Trojan swarms, which could provide opportunities to observe Trojan 1 up close. Data Relay Satellites, Tracking and Data Relay Satellite System, TDRSS. NASA's TDRSS is a network of geosynchronous satellites that facilitate communication with spacecraft. While primarily supporting near-Earth missions, TDRSS could assist in relaying data from other assets observing Trojan 1. Laser Communications Relay Demonstration, LCRD. This NASA mission tests laser communication in space, offering higher data rates than traditional radio frequency systems. LCRD could serve as a model for future high-bandwidth data relay from deep space missions observing Trojan 1. Proposed concepts: interplanetary communication relays. Studies have proposed deploying relay satellites at strategic locations, such as Lagrange points, to facilitate continuous communication with deep space missions. Implementing such a network could ensure uninterrupted data flow from assets monitoring Trojan 1, even when direct communication paths are obstructed by the Sun. By leveraging these existing and proposed assets, continuous observation and data relay concerning Trojan 1 can be maintained, even during periods when direct Earth-based communication is hindered by solar positioning. Projected timeline for Project Argonaut, April 14, 2024. Trojan 1 is discovered. Immediate observation with Hubble, JWST, and radio telescopes begins. Mission proposals are drafted by an international space agency coalition. Late 2024, early 2025. Mission approval and funding secured. Global space agencies, NASA, ESA, CNSA, ISRO, etc. Approve Project Argonaut. Work begins on designing the 4 probes, Odysseus, Aeneas, Juche, Agni. Space agencies consider leveraging existing probe designs, e.g. Mars, Jupiter, and asteroid missions, for a faster turnaround. Mid to late 2025, probe construction and testing begins. Hardware development for deep space navigation, communication, and AI analysis. Extensive simulations and environmental testing. 2026 to 2027. Final construction and launch preparation. All probes undergo final assembly and deep space communication tests. If high priority status is maintained, launch could occur by mid to late 2027, late 2027, early 2028. Launch window for Project Argonaut. Trajectories are optimized for the fastest approach to L4. The journey to Trojan 1 takes 2 to 3 years, depending on propulsion and orbital positioning. 2029 to 2030. Probes arrive at Trojan 1.